Hello everyone, welcome to the session on analysis and design of algorithm. So in today's session we are going to discuss some of the problems on asymptotic notations and the theorem based on the asymptotic notations whatever we have. Okay. So in the previous class we have discussed what are all the different types of asymptotic notations we have, and we have discussed what are all the constraints whenever we are going to represent our equation in any of the asymptotic notations like big O, big omega and big theta. So in today's session let us learn how to represent the given equation using the asymptotic notation. Okay. So already in the previous session we have represented the equation using big O notation. Today's session let us see how to represent a given equation using big omega and big theta. Okay. So let us see. So here before going to that, let me write the constraints whatever we have if I want to represent the algorithm efficiency in terms of f of n. Okay. So f of n is said to be belongs to big O of g of n if and only if. So what is the constraint? So the constraint is nothing but here. So if we holds good this constraint, then only we can say that your f of n belongs to g of n, right? So that is the constraint is your f of n should be lesser than or equal to c into g of n. So for all n greater than n naught or equal to. Okay. In the similar way, if I want to represent our f of n which belongs to big omega of g of n, the constraint should be holds good as f of n should be greater than or equal to c into g of n. So for all n greater than n naught. Okay. This is the constraint for what? If I want to represent our efficiency function in terms of what? Big omega. So if I want to represent in a big theta, then the constraint going to be followed as if I want to represent our big of f of n belongs to big theta of g of n, then we are going to c2 into g of n should be less than or equal to your f of n is lies between c1 into g of n for all n greater than n naught. So these are the constraints to be followed whenever we are representing in any of the asymptotic notations. So let us take simple example, simple equation. Let us represent in big omega notation. Okay. So the problem, take up the next problem, that is, so let me take this, represent f of n is equal to 100n plus 5, okay, in big omega notation. In big omega notation we need to represent it. So by the definition, so what is the given equation? So given equation is f of n is equal to 100n plus 5. So firstly we need to write what is the given is. Given equation is f of n is equal to 100n plus 5, right. So according to the definition of big omega, since we need to represent in big omega, so what is the definition of big omega? So the definition of big omega, according to this, your f of n is said to be big omega of g of n if and only if f of n belongs to, so it should be greater than what? C into g of n for all n greater than or equal to n naught. Okay. So in the previous class itself we have discussed what is C and what is n naught is. Okay. So let me take, so according to the definition of big omega, what we can say, your f of n is said to belongs to g of n if and only if your f of n should be greater than or equal to c into g of n for all n greater than or equal to n naught, right. So now, so what is f of n here? 100 n plus 5 which should be greater than or equal to C into G of n. What is that C into G of n now we need to consider? So, the given equation is 100n plus 5. Okay, this is your f of n. Okay, so you need to obtain the C into G of n such that this C into G of n should be lesser than your f of n. So for that what we can do is we can neglect the lower order terms. Okay, so you can just neglect the lower order term. Say for example, if you have a 10n square plus 10n plus 10 or 5 anything. So if you have a polynomial equation like this, by that time what we can do is we can just neglect the lower order term. Okay, so now what happens, you will obtain what, only 100n. So you have only 100n in the right hand side, that is C into G of n. So now what happens, so C into G of n is 100 n, so 100 into n for all. So we need to find out what is that n naught value is. So for that what we need to do, we need to give the value for n. So left hand side is what, f of n. F of n is nothing but 100n plus 5 less should be greater than or equal to 100n. Okay, so why? Because since we need to represent in big omega, according to big omega your f of n should be greater than what, C into G of n. So C into G of n, we have neglected the lower order term since it is a positive integer we are going to add into this equation. That's why I am neglecting the lower order term. In case if you had a minus 5, by that time what we are doing, in 100n we are reducing the 5. So what we need to do, we can't neglect the lower order term by that time. Okay, you need to convert that lower order term into what, the higher order term, and then you need to perform some operation. Okay, but here since we have a addition, so you can subtract, you can neglect the lower order terms. So once you neglect the lower order term, so this will be your f of n and this will be your C into G of n, which is having the constraint greater than or equal to. So now if you give the value for n, so when n is equal to 0, what happens, 5 greater than or equal to 0, is it true? Yes, true. So when n is equal to 1, so when n is equal to 105 greater than or equal to 100. So this is also true. Okay, next, so when n is equal to 2, so when n is equal to 205 which is greater than or equal to 200. This is also true. For n, for the given n values of, if you increment the n values here, n is equal to 3, definitely it is 305 is greater than 300, definitely it will be the true. So if you increment the n values, definitely for all the given n values, this ascertainment will be holds good, the property will be holds good. Therefore your n naught will be, so at what condition this holds good? At when n is equal to 0 itself, it is holds good in the properties. So therefore what is the n naught? N naught will be 0 itself. Okay, in case if any for any n value, if this ascertainment get failed, by that time you need to consider from the next point, okay, where actually it will be true. Okay, from that point you can consider that is as a absolute value, that is called as an n naught. Okay, so now your n naught will be equal to 0. Okay, so since it start from this when n is equal to 0 itself, this constraint is holds good, that's why. Okay, so then it is n naught is equal to 0. Therefore, so by comparing equation 1 and equation 2, what you will get, 1 and 2 you get, so this is your f of n, this is your C and this is your G of n. Therefore C is equal to 100 and n naught is equal to 0 and G of n is equal to n. So according to the definition of big omega, we can say that your f of n belongs to big omega of G of n. So what is f of n? 100n plus 5. 100n plus 5 belongs to what? Big omega of g of n. What is g of n? G of n is nothing but n. So, for the given equation 100n plus 5, so this can be represented in 100n plus 5 which belongs to what? Big omega of n. Okay. So, for the given values of C is equal to 100 and n naught is equal to 0 and g of n is equal to n. Okay. So, for this statement, so we can represent the, for the given polynomial equation, we can represent the equation in big omega. Same example I will continue. Why? Because in the right hand side already we have proved, that is your f of n should be greater than or equal to. For that what we have used, so that is 100n we have used. Right hand side we have already proved when n naught is equal to 0, by that time only it is true. But here we need to concentrate on what? So if I want to represent in big theta, then you need to have two statements, right? So your f of n lies between c1 into g of n and c2 into g of n for all n greater than n naught. So here remember the n naught value should be taken based on both the conditions should be true. So if both the conditions are true, then only you can consider that n naught as the value, absolute value. Okay. So let us prove this equation. So let us prove in the big theta notation. So for this, the big theta notation, what is the definition? F of n belongs to big theta of g of n if and only if your f of n lies between c1 into g of n and c2 into g of n for all n greater than or n naught. Okay. So let me take given value. So given value is what? F of n is equal to 100n plus 5. But here we need to prove what? Left hand side and the right hand side. So for that let me take here. So that is first one. So let me take this f of n is greater than or equal to c2 into g of n, that is nothing but 100n plus 5 should be converted into c2 into g of n format, right? So already we have proved this. So f of n is nothing but 100n plus 5 which is greater than or equal to, already we have proved that in the big omega, right? So that is 100n and we are neglecting the lower order term here. Only we are considering the higher order term, okay, and we are neglecting the lower order terms, okay. So now what happens if I give the value for n? So when n is equal to 0, so 5 greater than or equal to 0, true. So when n is equal to 1, so here 100 plus 5, 105 greater than or equal to 100, this is also true. When n is equal to 2, so that is 205 greater than or equal to 200, this is also true. For n number of values it will be true only. So this is for what? The right hand side, your n naught is equal to what? 0. Okay. And now we need to prove what? The right hand side one. So that is your f of n should be lesser than or equal to c1 into g of n. C1 into g of n. So if I look into this, definitely it look like what? Your big O notation constraint, right? So for that what we need to do? So whatever the f of n we have given, that is 100n plus 5. So just we need to take the higher order term, along with that if you have a lower order term, just convert into higher order term, that's it. So replace higher order term by replace the lower order term, by higher order terms. What you will get? So 100n plus 5 less than or equal to 100n plus 5 is the lower order term. So convert this 5n into 100n, nth term. So that by that time what will become? 100n plus 5 into n. What happens? 100n plus 5n. So it will be equal to what? 105 n and 100n plus 5. This is your f of n and this is your C1 into g of n. Okay. So now what happens? So if I give the value for n, so if n is equal to 0, what happens? So 5 less than or equal to 0, true. So when n is equal to 1, so 105 less than or equal to 105. This is also true. Okay. When n is equal to 2. So when n is equal to 2, 200 plus 5, 205. 205 is less than or equal to 210. Right. So 105 into 2 is what? So 210. This is also Holt's code. This is also true. So now from which case it is true? So when n is equal to 0 itself it is true. Therefore what is n naught? N naught is equal to 0 itself. In this case also, in the left hand side also n naught is equal to 0. In the right hand side also n naught is equal to 0. So let us write it in the equation here. Given equation is f of n is equal to 100n plus 5. We need to represent in big theta. According to the definition of big theta, your f of n belongs to big theta of g of n. When we can say this, if and only if your f of n should be lies between your C2 into g of n and C1 into g of n for all n greater than n naught or equal to n naught. Okay. So now what is C2 into g of n? So that is the left hand side whatever we have proved, that is 100n is your C2 into g of n less than or equal to what is your f of n? F of n is nothing but 100n plus 5 less than or equal to C1 into g of n. The right hand side whatever we have proved, that is 105 into n for all, for both the conditions when it has been Holt's code, when n naught is equal to 0 itself it has been Holt's code. Therefore your n is greater than or equal to 0. Okay. So now by comparing the equation 1 and 2, so let me call this one 1 and let me call this equation as 2. By comparing equation 1 and 2, so what we will get? We get, so C2 is equal to 100, C1 is equal to 105 and g of n is equal to, see, g of n is in this case also n, in this case also n. So and what is your n naught? And n naught is equal to 0. At when n is equal to 0 itself it is Holt's coding, right? So because of that reason, so n naught is equal to 0 itself. Okay. So now according to the definition of big theta, what we can say? Your f of n belongs to big theta of g of n. So that is nothing but what is your f of n? That is 100n plus 5 belongs to big theta of g of n. What is g of n? G of n is nothing but n. Hence proved. Okay. So here for the given equation, whatever the polynomial equation we get, so we are going to represent using either big omega, big theta or big O. Okay. Based on what? Based on these constraints. So either f of n less than or equal to c into g of n if I want to represent in big O. Your f of n should be greater than or equal to c into g of n if I want to represent my polynomial equation in big omega. So if f of n is lies between c1 into c2 g of n, then big theta. Okay. So using these constraints you can represent the algorithm efficiency or order of growth of the algorithm using any of this asymptotic notations. Okay. We are going to learn the theorem which is based on the algorithm efficiency of any two algorithms. So basically we know that algorithm is nothing but a solution, right, for a given problem. As we know that for a single problem we can have multiple solution, right. So for that multiple solution we may have different order of growth. Say for example here F1 is one order of growth and F2 is another order of growth. So, if both are belongs to big O of G1 of n and big O of G2 of n, then what will be the order of growth of that particular algorithm? So, say for example, if the one single algorithm have multiple solution in the same program itself, multiple part, so by that time, so what will be the algorithm efficiency? Finally, what we can say. So, what is the algorithm efficiency is? Okay. So, by that time, we are going to represent using this statement, that is F1 of n plus F2 of n belongs to big O of max of G1 of n comma G2 of n. Okay. So, this is what we need to prove. So, here basically if your problem have two parts, okay, in that, so if both are have to be considered, and by that time what will be the order of growth of your algorithm, or else what is the efficiency of that particular program, or sorry, algorithm which have more than one basic operation we can consider. Say for example, if I want to search any number, okay, in a given unordered list, okay, using binary search. If you consider the binary search, okay, and if I want to search for a given number in an unordered list, so in binary search, is it possible to search the element in the unordered list? No, right? We need to sort it and then we need to search for the element, right? So, here in the same problem we have encountered with two solutions. One is first we are sorting it, next we are doing what? The searching operation we are performing. So, therefore, among those two operations, so what will be the order of growth or what will be the time efficiency of that particular function is the question. Okay. So, for that the result is, or the answer is this one. So, you can say F1 plus F2. So, the efficiency of your searching, efficiency of your binary search, all together what we can say is big O of max of G1 of n or G2 of n. Any one of, if any one is greater, that one we can consider and that one will become your order of growth of the algorithm. Say for example, if the sorting algorithm is having the efficiency of n square, okay, and your binary search algorithm is n log n, definitely, so sorry, log n, okay. So, among those two, which one will be the greater one? N square is the greater one, right? So, therefore, totally what we can say that, so for that particular problem, we are considering n square as the time complexity of that particular algorithm. So, that is what we are going to prove in this theorem, okay. So, what is the given? What they have given is F1 belongs to what? G1 of big O of G1 of n. F2 belongs to what? Big O of G2 of n. Okay. Two things they have given, and if you are adding those two, what will be the combined solution or combined order of growth? So, what is that? Either G1 of n or G2 of n, we need to prove it. So, in order to prove this, we are going to use the some equation. So, in order to prove this algorithm, here we are taking simple arbitrary numbers, like let me take A1, A2 and B1, B2. Okay. So, if I say if A1 is less than or equal to B1 and A2 is less than or equal to B2, then A1 plus A2 will be less than or equal to 2 into max of B1 comma B2. So, this is what the ascertainment we are going to use to prove this algorithm. So, say for example, let me take the values for this to prove this. So, 1 comma 3. So, this is A1, this is A2 and 2 comma 4 is B1 and B2. Okay. So, let me check the values here. A1 less than or equal to B1. Okay. 1 less than or equal to 2. Is it true? True. And then A2 is 3 less than or equal to 4. Yes, 3 is less than 4. Then we need to check this condition. What is that? A1 plus A2. What is A1? 1 plus A2 is what? 3 is less than or equal to 2 into max of B1 comma B2. What is B1 comma B2? 2 comma 4. So among these two, which one will be the greater one? That we need to take. So 1 plus 3 is what? 4. 4 will be less than or equal to. So among this, 4 is the greater one. 4 into 2 is what? 8. So this holds good the property. So by making using of this property, we are solving this equation. Okay. So according to the big O notation, what is the definition of big O? If I want to represent f of n belongs to big O of g of n, if and only if what? F of n is less than or equal to c into g of n, right? So according to the definition of big O, your f of n belongs to big O of g of n. So if and only if your f of n is lesser than or equal to c into g of n for all n greater than or equal to n naught. We know, right? We know this, right? So according to the definition of big O. Okay. So now, so whatever the equation they have given, that is f1 of f1 belongs to what? Big O of g1 of n. So they are only saying that f1 belongs to what? Big O of g of n. Then based on this equation, can we write for the given value, that is f1 of n is belongs to big O of g1 of n, means your f of n is lesser than or equal to c1 into g of n, right? So g1 of n for all n greater than or equal to n1. Okay. So since it is a first equation, so making this one as a first equation for the first value whatever they have given. Based on that, we have written according to the definition of big O, what we have written, f1 of n is less than or equal to c1 into g1 of n. Why? Because they have given that f of n is belongs to what? Big O of g1 of n. That's why we have written this equation. Next, according to the same definition, that is big O definition, f2 is also belongs to what? Big O of g2 of n. So again, according to the definition of big O, what we can write? f2 of n is less than or equal to c2 into g2 of n for all n greater than or equal to n2. Okay. Let me call this one equation as 2. Okay. And here, in order to come up with this equation, that is in the left hand side. So here we are making using of these ascertainment only. What is that? A1 plus A2 will be lesser than or equal to 2 into max of B1 and B2. See, here also lesser than or equal to, here also it is lesser than or equal to. If I add these two equation, what happens? F1 of n plus F2 of n. This is like A1 plus A2, which would be lesser than or equal to, this whole thing can be considered as an B1 and B2. Okay. So for that, what we can write? So and also we have C1 and C2, right? So I will make one more assumption that C3 will be either C1 or C2. Which one will be the maximum? That one we are going to consider. That's it. Okay. Since it is a constant value, we can come up with the maximum value here. So C3 can be considered as an maximum of C1 and C2, and n can be considered as an maximum of n1 and n2. Therefore, by adding the equation 1 and 2, what we will get? So in the left hand side, if I add these two equations in the left hand side, we will get what? f1 of n plus f2 of n. That is what we have written here. f1 of n plus f2 of n. What will be the right hand side? So I am telling that C1 and C2 belongs to what? C3. Any one of the maximum value we need to treat. So therefore what we can write is, so C3, so you replace C1 and C2 by C3 itself. So like that. Okay. So here if you add for the first time C1 into G1 of n plus C2 into G2 of n. Next, so just converting these C1 and C2. Why? Because I have our assumption that so C3 is equal to what? Max of either C1 or C2. Okay. So because of that reason, just I am converting C3 and C3. Just take the common factor from these equation, that is C3. We have taken the common factor. We have left out with G1 of n plus G2 of n. So G2 of n. See, come back to this one. So here A1 and A2, B1 and B2, if you have these two, and if the constraint is A1 is less than B1 and A2 is less than or equal to B2, the same constraints we have, right? So based on this, what we can write is 2 into max of B1 and B2. What is B1 and B2? G1 of n and G2 of n. So that is what we have written here. So here C3, as usual we have written, take the same term C3 into, this can be written as G1 of n plus G2 of n can be written as 2 into max of G1 of n comma G2 of n by making using of this assumption. Okay. So after that, what we can write is, yes, of course, in the left hand side we have f1 of n plus f2 of n, which is lesser than or equal to C3 into 2 into max of G1 of n or G2 of n. So by the definition, what we can write? See, it belongs to this. So whole term can be treated as in what? So this can be treated as in C into G of n. Therefore, what we can write here, what is G of n? Max of G1 of n, G2 of n. Therefore, f1 of n plus f2 of n also belongs to what? Big O of max of G1 comma G1 of n and G2 of n. Among these two, which one will be the greater one? That will be considered as an order of growth of this algorithm efficiency, that is for f1 of n plus f2 of n. Hence, it is proved. And for the given values, as we taken the assumption that C3 will be the max of what? C1 or C2, any one value. Okay. And also N0 is what? So N0 is nothing but any one of N1 and N2. Okay. Hence it is proved. Okay. If you have more than one order of growth in the same algorithm, then we need to use this theorem. Okay, in order to obtain the order of growth of that particular algorithm. Thank you.